Hi guys, this is Sahil from the 3S TUTBUDDIES. Today I brought to you the Ohm's Law. The Ohm's Law is the one of the most important laws in the field of electrical engineering. This law is used to calculate the various important parameters in an electrical circuit, for example, the voltage, the current, the resistance, etc. So, the Ohm's law was devised by the physicist Sir George Ohm. In the Ohm's law, today we will study about the introduction to the Ohm's law, and using the Ohm's law today we will learn how to solve or how to calculate the equivalent resistance in a series and parallel combination of resistances. Now coming on to the Ohm's law. What is Ohm's law? According to the Ohm's law, in any circuit, the voltage or the potential difference across any resistance or any appliance is directly proportional to the current flowing through the circuit or the appliance. So symbolically we can represent it as V proportional to I. We can write it as V equals to I into R, where R is the constant of proportionality and R is known as the resistance. The resistance now is the property of any appliance or any resistor by virtue of which the appliance restricts the flow of the electric charge through it and hence provides a resistance to the flow of the electric current. Now from the Ohm's law, let us give you a pictorial representation of the Ohm's law. We have a circuit in which we have a cell giving a potential of E, a resistor R, a current flowing through the resistor I. Now the net voltage across the resistor will be E. Now E is proportional to I, where I is the current flowing through the resistor. Now E equals to I into R, which is the required relation. Now we will study about the series and parallel connection. Firstly, the series combination of resistors. In a series combination, the positive node of the combination of resistors are connected to the positive node of the battery, and the negative node of the combination of the resistors are connected to the negative node of the battery. However guys, the positive node of each resistor is connected to the negative node of the another, and the negative node is connected to the positive node of the another. Now let us give a pictorial representation of the series combination of resistances. We have a simple series circuit in which we have three resistors named R1, R2 and R3, a cell giving a constant potential of E1, current I is flowing through the circuit. Let V1 be the potential across the resistor R1, V2 be the potential across the resistors R2, and V3 be the potential across the resistors R3. Now, in a series combination of resistances, same current flows through the resistors R1, R2 and R3. Now, when the current is same, the net voltage E, which is provided by the cell, is divided among R1, R2 and R3. Now, we have the net potential E is equals to V1 plus V2 plus V3. Now, across individual resistances, let's say according to Ohm's law, V1 equals to I into R1, V2 equals to I into R2 and V3 equals to I into R3. Now we know E equals to V1 plus V2 plus V3, which implies I which is the net current, into the equivalent resistance called R equivalent equals to IR1 plus IR2 plus IR3. Taking I common on the right hand side, we have I whole into R1 plus R2 plus R3 equals to I into R equivalent. Now cancelling the I or the current from both LHS and RHS, we have R equivalent equals to R1 plus R2 plus R3, which is the required relation. So from this we get that in a series combination of resistances, R equivalent equals to R1 plus R2 plus R3 plus R4 plus up to Rn if there are n resistors connected in a series combination. So R equivalent in series is equal to summation of resistances from n equals to 1 to n Rn. This is the required relationship. Now let us solve an exemplar problem involving the series combination of resistors. We have a similar series circuit. A potential of 6 volt is provided to resistors 1 ohm, 2 ohm and 3 ohm. Now we could have questions like what will be the equivalent resistance, what will be the current in the circuit, and lastly what will be the potential difference or what will be the voltage, you can say, across each resistor. Now let us solve these questions. The first one, what will be the R equivalent? Since this is a series combination of resistances, we know that R equivalent equals to R1 plus R2 plus R3. That is, R equivalent equals to 1 ohm plus 2 ohm plus 3 ohm equals to 6 ohm. Now, what will be the current across the resistors? Or what will be the current in the circuit? The current in the circuit, we know that the net potential provided by the cell, which is equal to 6 volt, is equals to I, which is the current flowing through the circuit, into the R equivalent. Let I be the current. So E is 6 volt equals to I into R equivalent. We have calculated it as 6 ohm. So I into 6 ohm. Now I, or the current in the circuit, is 6 by 6 equals to 1 ampere. Now this current of 1 ampere is flowing through all the resistors. Now the third question, what will the voltage across each resistors? Now voltage V1, which could be the voltage across the resistance R1, is equals to I into R1 according to Ohm's law. So I into R1 equals to 1 into R1 is 1 ohm, so it is 1 volt. Now V2, which is the voltage across the resistor R2, is I into R2, it's equal to 1 ampere into it's 2 ohm, so it's 2 volt. Now V3 equals to I into R3, that is 1 ampere into 3 ohm, it's 3 volts. Now this completes our series combination of resistance. So hope you guys have understood the series combination. Now let us move to the parallel combination of resistances. Now what is parallel combination of resistances? In the parallel combination of resistances, the potential, the nodes, the positive nodes of the combination of the resistance as well as each resistor is connected to the positive node of the cell, and the negative is connected to the negative node of the cell. However, the positive node of each resistor is connected to the positive node of another, and the negative node of each resistor is connected to the negative of the another. Let us have a pictorial representation of parallel combination of resistors. This is a parallel combination of resistors consisting of three resistors R1, R2 and R3, having a battery which provides a potential of E. We have current I flowing through the entire circuit. However, in a parallel combination of resistors, what divides is not the voltage but the current. The voltage E will be same across each of the resistors. So what divides is current I1, I2 and I3 across the resistances R1, R2 and R3 respectively. Now let us deduce the formula for the equivalent resistors in a parallel combination of resistors. Now in a parallel combination of resistors, since the current divides, now the net current I equals to I1 plus I2 plus I3 across the resistances R1, R2 and R3 respectively. Now across the resistors R1, R2 and R3 the potential remains constant, that is E. So I1 can be written as E by R1 plus E by R2 plus E by R3, which will be equal to the net current I. The net current I can be E by R equivalent. Now taking E common from the RHS, we have E whole into 1 by R1 plus 1 by R2 plus 1 by R3. Cancelling the potential from both LHS and RHS, we get 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3, which is the required relation. So we got that in a parallel combination of resistors, the 1 by R equivalent is equals to summation of n equals to 1 to n, it's 1 by Rn. This is the required relation for the R equivalent in the parallel combination of resistors. Now guys, let us solve a exemplar question on parallel combination of resistors. Let us take a similar circuit. Let R1 is equals to 1 ohm, it's 2 ohm, it's 3 ohm. Let us have a potential battery giving a constant potential of 6 volts. Now we have a parallel combination of resistors having three resistances, 1 ohm, 2 ohm and 3 ohm, and a battery giving a potential of 6 volts. Now the first question can be what will be the equivalent resistance of the circuit. Second question may be what is the current in the circuit, and the third question is what is the current in each branch. Now let us solve the first question. What is the equivalent resistance? In the series circuit we know that in the parallel circuit we know that the 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Now 1 by R equivalent is equals to 1 by 1 ohm plus 1 by 2 ohm plus 1 by 3 ohm. It can be 6 ohm, it's the LCM, 6 ohm plus 3 ohm plus 2 ohm, that's 11 by 6 ohm. It's 1 by R equivalent. Now reciprocating it, R equivalent equals to 6 by 11 ohm, which is the required answer. Now let us move to the second question. In the second question we have been asked the current in the entire circuit. According to the Ohm's law, the current in the entire circuit I equivalent will be equals to E, which is the net potential, by the R equivalent. It's equal to 6 volt by Now the E by R equivalent equals to 6 volts by R equivalent is, as we know, it's 6 by 11 ohm. So the I net equals to 6 into 11 by 6, that is 11 ampere, which is the current in the entire circuit. Now moving on to the third question, we have the current in the all the branches. Now in the resistor R1, the current is E by R1, that is E is 6 volts, R1 is 1 ohm, that is 6 ampere in the 6 ohm resistor. Now in the resistor R2, the current will be 6 volts E by R2, that is 6 volts by 2 ohm, that is 3 ampere. And in the resistor R3, the current will be E by R3, that is 6 by 3 ohm, that is 2 ampere of current. This is I1, this is I2, and this is I3. Now we will consider a complex circuit in which there are n resistors of equal resistances in series, and there are m number of rows. Let us have a pictorial representation of that circuit. We have a shell giving a potential of E. Now there are n number of resistances in each row, R3 up to its Rn. Similarly, R2, R3 up to its Rn. Now there are n number of rows, it's m rows. Now in the first line, say in the first row, all the resistances are in series, so the R equivalent 1, or the equivalent resistance for the first row, it's R1 plus R2 plus R3, it's up to Rn, which is equals to NR if R1 equals to R2 equals to R3 equals to up to Rn. That's the given condition. Now if we have m rows, then the R equivalent will be, or it's 1 by R equivalent will be 1 by NR plus 1 by NR plus 1 by NR, it up to m times. Now 1 by R equivalent equals to m by NR, so R equivalent after reciprocating equals to NR by M, which is the required relationship. So guys, this is the completion of the video. If you liked, please like the video and subscribe. Hope you guys understood everything about the series parallel combination of the resistors, and the most importantly the Ohm's law, which was the today's topic. So guys, please like, subscribe and help us grow, so that we can help you to learn more and more things. So it's Sahil signing off from the desk. Goodbye guys, happy learning.